Okay, volumes of solids. Now we're talking about volume, and so we're talking about not just the outside, but filling up the inside. So lots of shapes, everything in our everyday world is a solid figure that will need to be filled up. So all kinds of shape. This would be, the grocery store would be a trapezoidal prism, and then you got a truncated cone right here because it comes inward. All right, kind of cone shape, plus maybe a hemisphere on top there, and just all kinds of fun shapes. The formulas are going to be similar to what we did with surface area, but not as difficult, so that's good news. So y'all probably don't remember these, but in my lifetime we used CDs for music, movies, and all that, or DVDs. And they used to come in this big tower. You could buy a whole bunch of them stacked up. And so if you think about the stack of CDs or DVDs, the bottom one is a circle, and you just keep filling it and filling it and filling it until it gets all the way to the top. So all you've done is take the circle formula and multiply it by whatever height it is. Well, that's what your formula for most of your volumes are. The base, whatever kind of base it is, times the height. But the base is not just one number, the base is whatever kind of shape that is. From the big B, that's a circle, pi r squared, and then times the height, and that's your volume formula. Okay. So you could have it as just big B times h, or you could go ahead and break it down like I showed you, pi r squared times height. Now, when you're ready to use a cone has been like a cylinder that's cut off. It's actually 1/3 the size, and so that's just a common thing that always happens, and they expect you to remember that formula compared to a cylinder for the ACT. It's 1/3 the size. I'll show you in class an example of it. Okay, and all these pyramids have the same kind of formula with the 1/3 out in front of the big B. Now the big B could be a square base, could be a triangular base, could be a pentagon base. Whatever kind of base that you have, you're going to say that times the regular height going straight up, but then pyramids have that 1/3 in front of them because they don't have the two bases that match, and it makes it come out even. Alright, so our first one, we've got our rectangular prism, and there is a shortcut for rectangular prisms. You could do the big B times height and say, what's my big B? It's a little base times height for the rectangle. But with a plain rectangular prism, a box shape like this, you could do the easiest way, length times width times height. There's three numbers, 1, 2, 3, 10 times 6 times 4. That only works with rectangular prisms and not triangular or hexagonal or anything like that. It has to be a rectangular prism. So much quicker, right? Alright, so let's try with a hexagon base. So your formula is the big B, and our base is a hexagon, but we still start by getting the height out of the way. 15 is the height. Now, the big B is a hexagon. The formula is regular polygon formula, AP over 2 or 1/2 AP. And your apothem was your 12. And your perimeter, not 10, perimeter all the way around, 10, 10, 10, 10. My 10s aren't showing up. 10, 10. So that'll be 60. Your apothem was 12, and then take half of it or divide it by 2. Put it all in the calculator, 5,400 cubic inches. We measured in square inches for area. Area is always in squared amounts, okay, inches, centimeters, whatever. But volume is always going to be in cubic amounts. That means you're not just doing one direction, let's say. You're not just doing the square, flat. You're doing the cubic amount, which is 3D. And so you end up with that 3D figure. Okay? So, cubic inches. Triangular prism, our old buddy, okay? Always throws us off. Same formula. Big B times H. Get your height first. Now careful, what can the height, the main height connects the two bases. So there's my base, there's my base. What's connecting them? 18. Hopefully you know that by now. Alright, so then the big B. This is what I always say, let's redraw it by itself. The big B, the base with all the numbers, 9, 12, and 15. And so I've got to find my area, my big B formula of that triangle. 1/2 base times height, or base times height, divided by 2. You put that instead of the half. Plug in your base, your height, not the height you already used. This is the height of just that triangle. And multiply it all out. 972. So your cylinder, same formula, or you could go ahead and plug in the circle base. Circle is pi times radius squared. You can go ahead and leave that in. The height is 25 there, and then 15 is your radius. So pi 15 squared times 25, all in the calculator in one shot. You can round that off to a whole number or a decimal. I think on my form, I think I put it as a whole number. Alright, and pyramids, remember I'll show you one in class how it works, but it's got the 1/3 in the formula. Same difference though, we're still using the height, the regular old height, straight up and down, not the slant height, so we're not using the 17 at all. Height is 15. Now, what kind of base is that? Let's think about it by itself. It is a rectangle base, 14 by 16. I'm not going to give you any that are parallelograms. That's too hard to see on there. It's turned sideways, so it's rectangle. Alright, so that'll be base times height for that rectangle. That BH is for that rectangle, your base right there. So 14 times 16. And then don't forget your 1/3. Now to put that in the calculator, you can do it all in one shot. Since it's all multiplying, you could say 16 times 14 times 15 and then divide by 3 at the end. 1/3 is just divided by 3. But if you want to put it out front, just say 1 divided by 3 times 16 times 14 times 15. Okay? 1,120 cubic inches. Finally, a cone works the same way. You got the 1/3 out front. This time it's a circle base, so your circle formula pops up again. Pi times radius squared, and 18 for the regular height of the middle. Now sometimes they'll put the height, if it's too cramped on the drawing, sometimes they'll put the height over to the side like that and say that's 18. That's your height going straight up when they do that. 1/3 times pi times 6 squared times 18. Okay, round it to 1 or 2 decimal places. And that's it. Oh, sphere. Forgot about sphere. And so the sphere has a radius going in any direction you choose. If you start at the center and you go that way, that's a radius, that way is a radius, any way you want to do it. Out to the edge, from the center to the edge, that's a radius of that sphere. Alright, so its formula is going to be different. We haven't talked about the formulas yet at all, that's spheres. But 4 times pi times radius squared, you take one circle and you say 4 times bigger, and that's the outside surface area. So like we had the basketball, we want to know how much leather does it take, how many square inches of leather does it take just to cover the outside. You use this formula, 4 pi r squared. And so that would be 4 times pi times the radius. 16 is not the radius. All right, it'd be 8.1 squared. I got it okay. And you get that 824 square inches of leather just to cover the surface, not including seams. Seams would just sew it together would probably be more. All right, now volume, filling it up. How much cubic air will the ball hold? Cubic inches of air. So little boxes of air, how much? So you use the formula 4/3 pi r cubed. So that's a little different when you put that in the calculator. 4 divided by 3, of course, times pi times 8.1 cubed. Now to get my calculators in there, if you got a graphing calculator, you might see a little button that says that. But on my calculators, they have a little button that says this, X with that. So you're going to hit 3 and then this button, okay? And then you put in your number. So in the calculator, it will look like 3 and then this and then the 8.1 gets put in there. Oh, that's a cube root. I'm sorry, forget that. Just cube it, you're going to do the little mountaintop. So 8, mountaintop 3. That's what you use, mountaintop. Alright, some calculators will have a cube button, okay, fancier ones. But mine, if you want a different power besides square, you're going to have to use the little mountaintop button. I was doing cube root. Alright, so now that's it. And that's what you should have gotten for an answer. Something close to that.